So good afternoon or good morning if you are a little west of me, and welcome to the July edition of the past Women in Technology Virtual. We're very pleased that you could join us today for some amazing training. We're lucky enough to be able to bring these things to you every month. We find them useful. Two sponsors. We have Century One and Redgate. Big thanks to them. They've been Century One's been a sponsor for several years now. Redgate came on about a year ago. So we're very pleased to have them, and there will be gift cards given away at the end of the session. Thanks to the generosity. You can check out this session and any session that's coming up that we've had in the past on our YouTube channel. You don't have to memorize or copy that anywhere. You can just use the password on YouTube. You should be able to find us. Check out the homepage. It's actually .pass.org. If you're not a member of our virtual chapter, you should be. I promise that we don't harass you, but you will get our monthly newsletter. And that contains some of the information that you're going to see here. It contains links to articles that you might highlight a blogger, a woman blogger every month. And if you want to follow us on Twitter at @PassOnCode. Follow and use the password hashtag. If you have news that you want to share, share every week, except for vacation. I tweet every female speaker. If I'm aware that she's doing a webinar, that she's doing a user group, but everyone that's speaking Saturday on Saturday, just to draw attention to the great things we're doing in tech. If you haven't registered for Past Summit yet, let me encourage you to attend. It's amazing. It's like nothing you'll ever experience as a professional. But if you do decide to register, use our discount code, we get credit for it, but you save $150 off registration. We have some upcoming sessions. Tracy and I were talking about these a little bit ago. Louisville is this Saturday. They have an amazing lineup of speakers, and so that's cool. And Tracy Boggiano, of course, is speaking there this Saturday, because Tracy doesn't know how to say no to people when they ask her to speak. Columbus, Ohio is the next weekend. I will be there speaking. And then not on this list, so a couple of weekends after that is Baton Rouge. I forgot my that's why she's not. I'll have to hold on. Coming up next month, Bobby Joe Brighton will talk about women's mental toughness in the tech industry. Looking forward to this kind of soft skills presentation. But today we have Tracy Boggiano, Intro to the Query Store. I will not get too deep into the description of the bio until you signed up for the webinar. I will turn the presenter over to Tracy. If you have any questions, you can type them into the questions right there on your GoToMeeting. And if it's pertinent to that slide, or your on, I'll ask them. If you need my attention for any reason, feel free to, again, just put your questions for me.
All right, can everybody see my slide deck?
I can.
Okay, cool. So we're going to talk about Query Store today. This is going to be a quick introduction to Query Store and all its features. I'm Tracy Boggiano, as Ree had introduced me. A little bio about myself. I've been working on SQL Server for almost 20 years. I'm getting very close to that, going all the way back to SQL 6.5. I'm an Adira Ace this year and was named an Adira Superstar. Don't know what that really means, but they made really cool duck pictures out of us when they did that, so that was kind of nice. My involvement with PASS is I lead a special interest group with advanced DBA topics in the local Raleigh area. I also lead getting Linux content into the existing virtual groups because there's not a group for Linux. Volunteer work-wise, I founded a website called We Speak Linux that does more general Linux topics because a lot of us only know Windows, and it's to help us learn Linux as more things are going to be on the Linux platform, and we need to probably learn both platforms. Also a member of speakingmentors.com to help more people get into speaking because I enjoy it so much, why not help other people do it? Also volunteer with abused and neglected foster children through the North Carolina Guardian Ad Litem program. I love to try to talk people into doing that. It's also known as the CASA program nationwide if it's not known as a Guardian Ad Litem program in your state. So I always encourage people to hit me up for more information about that as well. So enough about me, on to what we are here to talk about. So as far as a quick agenda, we're going to look at what Query Store can do for us in the SQL Server engine, how you go about setting it up, the different usage scenarios you have for Query Store and what those are, some extended events that are available for Query Store that you can use to monitor things, some best practices around Query Store, and then we're going to do a quick summary of everything. So what can Query Store do for us? One thing it can do is help us track down regress queries. So whenever you have bad performance going on in a query, you sometimes get parameter sniffing and you end up with different plans in your procedure cache, and you can go in and find those queries that regress in performance and decide what query that you want that plan to actually run and force that plan to run instead of a bad plan. And you can find queries that have changed because somebody's dropped an index or changed the index, or your data's changed and you need to add an index that you used to not need. So it gives you a quick, easy way to go in and find those things where you did not have this before without running SQL profile or extended events. You also can go in and just find your top consuming queries that are taking up the most resources on your machine. So if you notice you've got a lot of CPU being used or a lot of disk I/O, you can go in there and quickly find out what's consuming those particular type of resources on your machine and try to fix those queries to consume less of those resources. You can audit the history of your query plans. I've seen upwards of 20 plans per store procedure. It's kind of fun to try to figure out what's going on when you get all those different plans in there, and you need to try to figure out what is the best plan for a particular store procedure. So this gives you a complete history of what's going on as far back as you're keeping the data. And it gives you the resource usage patterns for your database. So you can see over a period of time what days you're using the most CPU, what days you're getting the most reads on your system, and try to determine your patterns of how your data is actually being used. So those are all important things that you need to know as a database administrator. In 2017, they also added the ability for you to get weight stats for your queries. So they sum these up into 23 different categories. We'll go over those a little bit more later. They also, instead of you actually having to force plans when you get regression, they also have the ability for it to just auto plan correct for you. And we'll actually do a demo on that and talk more about that later. So as far as setting it up, it's actually pretty simple to set up. You just run one simple command to turn it on. But of course, the default settings aren't all that great. So let's go over all the settings and what you might want to change. So the first setting is your operation mode. That by default will be in write mode, which is what you wanted, read-write mode, which is what you want it in. There is a read-only mode, and that's not very useful, and of course off. There's also the ability for it to go into an error state. I have a blog post about how you actually fix that. Microsoft's actually working on a bug fix for that because that is considered a rare race condition, even though I've seen it on over 50 databases in my environment. The data flush interval tells it how often to actually flush the data to disk, because by default it keeps that data in memory using in-memory OLTP. And so by default, it's set to 15 minutes. It's the data that if somebody pulled the power plug, that's the data you would lose out of Query Store. But if you set that really any lower, it will become the top consuming query on your system. I only did that on my test environment for the record. Your statistic collection interval tells it how often to roll that data up. What it does in the background is it really keeps that data aggregated. It doesn't keep each individual execution of the data. It aggregates that data up into like hour-long intervals or 30-minute intervals or 15-minute intervals. We keep ours at 15-minute intervals, but it defaults to an hour. Your max size is, I think, is the most important thing to change because it defaults to 100 megabytes, which isn't very big when you consider you're keeping plans, which can consume some space. I remember the first time I went in to play with Query Store, I got a little disappointed because we had left it at the defaults and it already stuck it in read-only mode because we didn't have the auto cleanup turned on and there was no current data to look at because it was at 100 megs. I recommend setting this at about 2 gigs. That's what we found in our environment. If you're using a lot of store procedures, that's enough to keep about a month's worth of data we found in our environment. If you're using a lot of ad hoc queries, you're probably going to have to set this differently, or you can set up a job to actually clean out any ad hoc queries if you don't need to keep that data for longer. That way you can actually just keep your store procedures in there. For your Query Store capture mode, this is set by default to all, so it will capture everything that runs, including your ad hoc stuff and your store procedures. You can set it to auto so that it will just throw away trivial plans like a simple select statement that doesn't have to have a complicated plan. It'll just throw that away and not keep it. I like to have it on all because I like to know everything that runs on my system just in case there's something that does a large read or takes a lot of memory because it had to do a large scan on something. Size-based cleanup mode, I like to leave that on auto as well because when it reaches that 2 gig limit, if it reaches that limit and it's not set to clean up, it will automatically stick it in read-only mode and then it's of no use to me anymore. So you want to leave that turned on by default. So that's a good setting to make sure you leave turned on. Your state query threshold, they set this to 367 days, so I guess they took into account a leap year and a day for some reason. It's just a funny number for me. But I've left that alone on my system as well because I don't think it matters how long it keeps the query plans in the system because I've got the cleanup set to on. So out of all of these settings, the most important one to look at really is setting your max size, up that to at least 2 gigs, and look at your statistics collection interval, what sense it makes to you as far as what you want to roll that data into, whether hour-long intervals are detailed enough for you or not. So more on the Query Store setup is it's on your primary file group. So if you're using piecemeal restores and you try to go higher than like 2 gigs, you got to take that into account. So if you're wanting to keep more data and you want to do piecemeal restores, you're going to have to take into account the fact that you've got to restore that data first. We did log a connect item, which is now moved to, I can't remember what they call it, it's Feedback Azure, to try to get them to put this in its own file group back when it first started. So if you want to upvote that so you can actually put it in a different file group so it won't affect piecemeal restores and you can keep a larger query stored, there's a link for that in the slide deck. One other thing to note is you've got to turn this on per database. So whenever you're troubleshooting something, you got to go into each and every single database to look and see what's going on your server. And this can become a problem if you have a large amount of databases. You can enable it on your model database so it automatically enables whenever you create a new database. You can also enable it on MSDB database. You can only enable it on MSDB database using the command. You can't enable it using the GUI. On the system I have, you can see on the side there, I have like 300 and some databases. So it becomes a little troublesome trying to pick out which database might be the particular problem on the server. So I have another connect item where I think it would be nice to have a central repository so that you can actually go in and find the troublesome query on a particular system rather than trying to hunt and peck. I also have a PowerShell script that'll go through and find stuff for me as well. That'll go through all the databases, but at 300 databases, it's not really that safe to run. But on something that has 50, it is, and I will show you that later in the demo. But there's a link for that too if you're interested in trying to get that upvoted as well. Some trace flags that you can use as far as setting things up to make things run a little bit better is there's one for 7745 that if you notice that you're shutting down your system and it's taking a long time to shut down, you can tell it not to flush that 15 minutes worth of data to disk and just lose it. And so you can get your system to shut down faster. That's useful in systems like where you have 600 databases or 1,000 databases. On our systems that we do have that many databases, we do not have this enabled. We tried it. It didn't really bias anything, so we disabled it. Another trace flag that you can use is 7752, which tells it to asynchronously load the query store data. So if you see this particular wait type, the QDS load DB, this is for when it starts up. This tells it to load it behind the scenes so that you can actually get your system up faster. Again, this is probably useful on the systems that have 500-600 databases and a large query store. We have tried this on our system that had 600 databases. Did not find it was helpful in that particular system. But again, we've got a query store set pretty small. So if you get to a larger size query store, you may need to enable that setting. Or that trace flag. So in summary, the most important thing is to make sure you set your options, especially your size. Remember, it's on your primary file group. So if you've limited your size there so people don't put tables and indexes in there and keep those things separated, and you're using piecemeal restores, remember that you're going to have to take that in consideration when you decide what size you're going to use. It is per database, so you've got to write something that'll enable it per database. And you can use trace flags to control the shutdown and load up and start times for it. This is a screenshot. If you go into a database and go to the properties of the database and go to query store of where all the options are and what the defaults are, and it has nice little pie charts to tell you how much space it's using. And it's got a button down at the bottom where you can just go ahead and purge the data out if you need to. So it just gives you, if you just have one database, you need a quick, easy way to go in and enable it. You can do it that way as well. So just so you guys have a quick, easy way to do it without me having to go out and do a demo on that. So we'll briefly go over how Query Store actually works. I got this diagram out of Books Online. So at the top, we've got where the query actually executes, and it goes and it looks it up in the plan cache. Now, if it finds it in the plan cache, it'll actually take and go and look and see if it's been a forced plan or not in Query Store. If it's been forced, it's going to go and get that plan out of Query Store and use it instead. If not, it's going to use what's in the cache or compile a new plan if it needs to. Once it's done doing that, it's going to execute the query, and once it's finished executing, the nice cool part is the nice gray line on the screen where it actually takes the execution stats and stores it in Query Store so you can view it later. As I mentioned, that data is stored in in-memory OLTP, so it's available immediately for you to view, even though it's not stored on disk yet, because they just combine the data together when you go and query it. They get the data that's on disk and the data that's in memory for you to view immediately. So you're able to see the data instantly when you go into Query Store and see what's going on. So as far as reports go, they've got a few reports built into Studio, SSMS. I always try to say Enterprise Manager still. I'm a little old. But you can identify the queries that have degraded in performance in your regress query. So that they will have a number of queries listed in there, and you will see different plans for those queries, and it gives you a quick, easy way to go see which ones have degraded in performance over time. This is useful for when you have code changes or you've recently upgraded SQL Server and you've changed the compatibility mode, especially if you went from 2014 up to a new version of SQL Server and they had all those cardinality estimation changes. I recently did that on a system, and boy, there was a lot of regress queries. That was fun. So in there, it's very easy. They have a button that you can push where you can just force that plan, and you can go back in later and there's a force plan report, or you can go back in later and try to fix the query and make it better and able to use for the new cardinality estimator or whatever else may have been causing the degradation in performance. I've actually had to use this on Christmas Eve and basically save Christmas Eve in like 5 minutes, because all it took me to do was to log in and somebody told me which particular database was having the plan problem and told me what stored procedure it was, and I was able to quickly go in and just diagnose the problem and hit force plan and go back to having Christmas Eve. And my boss was kind of aghast that I used the GUI instead of using the little commands to do it, but you know, hey, it was Christmas Eve. So you can also force, you know, the plans are all coming from the history, so you're using every plan that you've got from the history, so you could have 20 different plans that are in there, and you can force any of those plans that are from your history. This is an example of what a report looks like that Microsoft put on Books Online. So the bottom plan is one that runs fast. The top plan is one that does not run fast. If you see the check marks, that means it was forced. So they just ran one, ran a bad one, ran a good one, ran a bad one. This is what one looks like in real life. So in real life, we'd probably want to force the green one on the screen, and we do not want that pink one running ever again in our whole entire lives, because it runs horribly bad in comparison to the green one. So this is to give you an example of it. We will actually go in and drill down into these reports later. So you can also check the status of force queries, because they can go in, they can actually fail if you've dropped the index or anything else that's part of that plan. So there's a field for that in the force plan in the query store, but they've also added a report in the newer versions of SSMS, so you can just go in there now. They did not have that in 17.3. I think they added it in 17.4. So if you're not updating that monthly, you probably should, except for last month when they had a bug, or this month. They also have an extended event in 2017 for it. The extended event, I believe, in 2016 did not actually work because it was in there for Azure and did not actually make it into the RTM version of 2016. They may have fixed that in the CU that I'm not aware of. But you can check to see if these force plans are actually working or not. And you need to know if they're working, because if they're not working, then you're doing extra work, because it's going and fetching that force plan, going, oh, I can't work, and then going and compiling a plan and actually using a different plan than what you forced, and then you still might be getting regressed performance that you're not aware of because you thought you fixed it, and now it's still doing the old stuff because something has changed behind the scenes that you're not aware of. So it's a good idea to keep an eye on these things. This is what an overall resource consumption report looks like. So in the top corner, we have just the duration, then we have the execution count and the CPU count down at the bottom, and the logical reads. At a point, we released code, index change, and we dropped our logical reads, and we were able to basically stabilize our CPU utilization, and our duration or execution counts went up. So this is a good way to see how a change has affected your system overall. So to me, this is a great change in our system that we were able to immediately see by just using Query Store, because we have all the data now going across the system. So as far as top consuming resources, you'll be able to go in here and look at forcing a plan because of regression, because you'll be able to see in that report what queries are the top consuming resources. You can drill down on each one of those bars that was in that report, and it'll take you into a report that shows you all the queries that are consuming your resources. You can take a look at what indexes are missing, because it'll show you the plans down at the bottom, just like you would if you were running the queries or displaying an estimated execution plan. It'll show you the green hints. Don't implement the green hints just the way they are. I have found at my new job, people have implemented them and left them with even the names that say missing index, comma, sys name. But pay attention to what you're implementing, in other words. Another way to help out some of the stuff is make sure your statistics are up to date. My new job did not do that before I started there. Make sure your indexes are defragged so your queries can run faster. These are all different things you can do to help out your top consuming, resources on your systems. Check out your queries, make sure they're running right. And if you got a really bad query, you need to rewrite that expensive query. I'm having to do that a lot at my new job. So I can't wait to actually upgrade at my new job and have query storage to be able to find some stuff, because finding it the old-fashioned way is not as much fun. They added a new report in 17.6 of SSMS that will tell you queries that just vary in their execution. So it has the same plan, but it just varies widely in how often it takes to run, or the duration reads or writes, or any of the other variables that it keeps up with. So you can go in here and check out things that are just, widely varying, and then you can try to diagnose why that's happening. So that's another report that you can look at. So we'll actually take a look at some reports in my VM on VentureWorks. So I ran a pretty random workload against VentureWorks. For the past few days, so that there would be some data in here. So this is what the overall resource consumption report looks like. Like I said, in the top corner, we've got the duration, we've got the execution count, the CPU time, and the logical reads. If we drill down on any one of these bars, it takes us to the top consuming resources, and we can see our queries down at the bottom if we click on one of the bars. And we can see we have a pretty gnarly looking query there that is doing a lot of stream aggregates and sorts and the like. But it's only got one plan. One thing you'll see is a square there that I haven't explained. That means the query errored out and did not finish. Probably just me turning off my machine in this case. In the top corner here, we have the ability to look at it by different variables. So if you don't want it by duration, you want to look at what's eating up your CPU instead, you can change it to that. And you've got other variables as well that you can look at. You can look at what's taking up the most wait time if you're in 2017 and check it out that way. And they also have it, instead of doing it by total, you could do average or maximum and use standard deviation. They also have it in grid format, so you can actually go in and see it by stored procedure name. So if there's a particular stored procedure you're trying to troubleshoot and see, you can actually go in here and try to find it and troubleshoot it from there. They have some other options on this side that can show you some information for that particular query, what the wait time, average time, and all that information is, because we're looking at wait time right now for our plan that we're looking at. So those are those two reports there, the overall resource consumption and the top resource consumptions. We don't have any force plans in this database, so we won't look at that. These are the queries that it thinks are varying, which it doesn't find many that are varying because my workload is pretty consistent as far as varying, because it's just calling the same stored procedures over and over and over. But if you had stuff that was varying, it would be in here. And if you had a particular query that you had forced before and you wanted to go back and check on it and you wrote it down, you could actually go in here and track that query. I think I have one memorized that I've used before. And I could go in here and see what it was doing and decide if I still wanted to keep it forced or not. And you've actually got the ability now to compare plans in here. So if you had two different plans, you could click on them and compare them and see what they look like together. So those are the basics of the reports that they have available for you in SSMS. So now to why they gave us Query Store, the different ways we can go about using it and why we would want to use it. And so some of these I've talked about. So for A/B testing, when you're rolling out a new version of your application, it's good to have some statistics on what's going on. So as you had seen previously, we rolled out some indexes and got a huge drop in what our reads were. But I've seen cases where we've rolled out an application and got an adverse effect. So we were able to go in and find out that one of our engineers had changed 300 stored procedures to use a table that didn't have an index. So we had to quickly put an index on there and fix that. So there are different things like that that you would want to take a look at and be able to keep an eye on your application. And it's very easy to go in and see those changes in performance when you're able to go in and drill down on those reports. If you add new hardware to a server, you can easily see what's going on with the server, or you decide to take away hardware from the server for cost savings. You can see if the server's still able to perform as well as it was before and what benefits or consequences there are to those decisions. You can also, when you're creating those missing indexes for those expensive queries, see what difference that is making on your environment. See if it actually reduced your reads and your CPU time and made things better or not. It also can be used to help you when you're upgrading SQL Server. So they made a lot of cardinality estimation changes in 2014. So if you're upgrading from 2014 up to 2016 or 2017, you can actually upgrade to 2016 or 2017 and leave it in the old compatibility mode for a week or a month to gather data. Enable Query Store, capture all the plans, and then set your compatibility mode to the newest compatibility mode. And then if anything regresses, you can actually force those plans back to what they were without having to set your compatibility mode back to 2014. So this helps you out in getting around all those questions that management gives you about what's going to happen if I upgrade and things break and run slower and things like that, and keeps you from having to roll back things that you don't necessarily want to roll back. Another use case scenario for it is finding out what all your ad hoc workloads are. I don't know about you, but I like to have everything as stored procedures rather than things running as ad hoc and filling up my plan cache and having all kinds of things just floating out there and filling things up. Because I like for my plan cache to be used for stored procedures and not have 1,000 plans in there that are basically the same thing with different things compiled because it's just got different last names with different links and stuff like that going on. So you can actually go in there and sort it by your execution count in the run stats and find things that are just run one time and see if the plans are similar and try to get those queries that are similar and convert them to stored procedures. So this is an example of what one would look like, and then you would go through and try to find those. There's also a query available in Books Online where you can pull those out and try to compare them and see which ones are the same so that you can convert those over and help out your plan cache some. So a summary of the usage scenarios, or you can use it for your A/B testing for your applications or when you make changes such as indexing and hardware changes. Use it for when you upgrade SQL Server and identify and improve your ad hoc workloads. On to the 2017 features. These are kind of cool. So you probably should just skip upgrading to 2016 and just go on over to 2017 would be my vote because these features are really neat. So we get us a new DMV called Query Store Wait Stats. I don't know about you, but troubleshooting with wait stats is really nice. So what they've done here is they put them into 23 different categories. So, because if they tracked every single wait stat, you're going to need a lot more than 2 gigs to keep up with everything. We went from 2016 to 2017 and did not even increase our 2 gigs, and we're still able to keep a month's worth of data because they kept this pretty small. So they track them in categories such as just CPU and memory. And on Books Online, they've actually got the different categories available, so you can see which things they put into each category if you need to know more detailed information about what those specific categories are. And they've got them completely documented as to which weight stats they put in each and every category. So you can drill down deeper into that. But this gives you a nice, easy way to see, you know, hey, this query's waiting on CPU, this query's waiting on memory, and so forth. And this one's waiting on buffer I/O. So the next coolest feature is the auto plan correction. And so instead of us having to go in there and force the plans, we can let QueryStore do it for us. So it's a lot less work on us. So the recommendations are surfaced in this DMV right here, and you can, without you doing anything, this information's available to you, and you can just have it there, and you can force plans when you want to force plans, and just check out the recommendations and do it as needed, or you can just turn it on. I turned it on some systems and got a 20% CPU and performance increase, which was really sweet. So it'll automatically switch to the last known good plan that it finds, and if that plan is no longer good, it'll switch back to another plan. So it'll switch it on and off based on what it finds. So it doesn't just force the plan and stay with it forever. If it finds that plan is no longer any good, it'll actually switch to another plan that is better. So that gives you, you know, some confidence that it actually knows what it's doing and won't just stick you in a bind by staying with a plan forever. Data in this DMV is there again even if you don't turn the option on. The only gotcha to this is all the data in this DMV is lost when you restart the SQL Server. So all those plans that it forced for you are no longer forced when you restart the server. It's like it's got to re-baseline everything when it starts over. So that's the only real gotcha there. So as far as setting it up, all you got to do is alter the database and say that you want to force the last good plan on, and then it's set up and ready to go. So the summary of the 2017 features is you got the auto plan correction and weight stats. Now, on to some demos and less talking. So we're going to go through quite a few demos here. First one we're going to look at is forcing a plan. So I'm going to turn QueryStore off for this one to make sure I had it reset. And I got this demo from Slava, and I'm not very good at saying his last name, so there's his last name so I won't butcher it. And I'm just going to go and double check and make sure I don't already have any forced plans. I did this earlier and I do, so let's I got it. I'll have to unforce that in a minute. So we'll get everything set up and unforce it. So basically we're going to make sure we don't have any data available and make sure I don't have my index that would make it run faster. And we're going to create an index and drop our procedure cache and update our statistics on this sales order header table. We'll turn it on so we can see our execution plan. I can't remember how to unforce it, but this demo may not work until I figure out how to unforce it. But for right now, we're going to select data from July and see what we get back. which we're not going to get anything back because you just see me delete it all, and see what execution plan we get. And now I should be able to go in and see that plan and unforce it.
So Tracy, okay.
Yes. There we go. Sorry, I couldn't quite hear you, Ree, so.
Give me a sec. Keep going.
Okay. Now it's unforced. We'll get our bad plan. So, I don't want to see all that. So, in our bad plan, we've got an index seek and a key lookup and a clustered index seek and some nested loops going on. So, we're going to see how we can get a better plan than this based on the data that we got. So, we've selected some data from the customer order header with the last name of Martin for July, and we've gotten nothing back, and we've sent in a nice query so that it's optimized. So what we're going to do to get some data is we're going to take the data from June and just add a month to it so that we have data for July and see what kind of plan we get after that. So it's going to give us 900 rows. And when we run the same query, we're going to get our same plan as before, but we're going to have done like 2,000 reads. So now what we're going to try to do is get that read count down. So one easy way to do that is update stats, because we just added like a month's worth of data. We just basically did an ETL load. Now by updating the stats, we're going to find that we're going to get a different plan. And we're going to reduce our reads to 700, which means we've gotten probably a different plan. Sorry, I keep hovering over things. But now we've got a plan where we just do an index seek and a clustered index scan, and we hash match it together, and we've just selected the exact same data. So now we should be able to go in our top consuming resources and view those two plans together. So now we've got two different plans that vary widely in their performance. And those are our plans from before: a good plan and our bad plan. And on Christmas Eve, you would just come in and hit force plan because you don't want to mess with T-SQL. And it also gives you a missing index in if you wanted to use it. So from now on, whenever you run this query, it's always going to use that plan, as you've seen, because I'd had it forced from the last time I had done it. So every time we rerun this, it's going to just run that same plan. No matter how many times we rerun data, it's just going to give us the same plan over and over again. So now, next month when they load this ETL data, or data just keeps changing over the month and month and month and month, it's just going to use the same thing over and over again and never change the plan. So now we'll just clean everything up and move to the next demo. Next, I just want to briefly show you some of the categories they have for weight stats that were generated on my machine while I was producing the workload. So most of mine, it didn't generate all 23, but most of mine were buffer IO stuff, and these are just in alphabetical order. So these are just the general names it gives for things. CPU, of course, you get idle time. I like the unknown category. It's my favorite description of the category ever. And then if you had a particular plan you wanted to look at, because you got the plan ID that we looked at earlier, you could go in there by that particular time and see what it was doing. Brenozar actually has a script where you can get it from his first responder kit, and you can go in there by a stored procedure and run it and pull it up. I've already ran it because it sometimes, as you see down in the corner, it takes about a minute to run sometimes because Microsoft didn't really index the DMVs very well. So I ran the version of his that just looks at a particular stored procedure and pulls back data, and it pulls back your weight stats for you. In this case, it actually didn't pull anything back, but you can run this on the whole database in debug mode. You can get the top one procedure. You can do it by dates, end dates. You can do both the end date and a start date. You can do a minimum execution count and a minimum duration. You can run one on if a stored procedure doesn't exist. Don't ask me why he gives that example. And you can actually look for failed queries as well. So that gives you another way to check for those failed queries. So as far as auto tuning goes, this demo takes a little while to run, but it's well worth seeing because it's neat. So we're just going to set up worldwide importers by clearing the procedure cache for it and clearing the query store and returning the auto tuning forcing planning off so that we can manually do things ourselves. I actually got this demo from Joe Sack, so I did not write it myself. So first we're going to do a baseline. We're going to go in and select the package type ID of 7. You've got to run it. He says at least 60 times. I found running it 300 is usually when I can get a good baseline in there. So this takes about a minute to run sometimes 20 seconds. Depends on how well my machine wants to behave. But what it's doing is establishing a baseline of, hey, this is how long this procedure takes to run. And then we will run it with a different package ID and run it only like 20 times, and it'll set a different baseline and then see what it recommends as the best plan. And then we'll run it again and let it automatically force it for us because we want to be doing other stuff as DBAs and because we've got enough work to do than forcing plans. So it took about 40 seconds there. So now we're going to clear out the procedure cache so it doesn't use that plan that it just generated. And we're going to select just run it one time with the package ID of 0. And that one runs pretty fast. And now we're going to run this one, that one we ran before with the package ID of 7. And we're just going to run it 20 times. And it's going to take a little while to run because it's using a different execution plan than before. So that took 7 seconds. And then it's all written in JSON, the recommendations here. And they have to have a score of at least a 10% improvement for it to run. So it's telling us that the CPU time will change from 259 milliseconds to 6 milliseconds if we take and force this plan. And it gives you the nice recommendation right there where you can just copy and paste and you can manually force this plan. And this is a way that you can force it forever. If you let it force it, like I said, it unforces when it restarts the server. So that's the only disadvantage to letting it do it. But at our shop, we're just letting it automatically do it, and we've seen a 20% increase in performance on most of our systems by doing it. For a more detailed report of what's going on, they have a longer JSON query here that can tell you what's going on. And it can tell you the score, what query ID it is, what the new plan would be, what the recommended plan is, and the estimated gain. And the estimated gain only has to be above 10 for it to actually use it, and we're getting an estimated gain of 79. So that's a lot of improvement there. So, and we're not going to force it so that we don't have to worry about unforcing it. So now we're going to go back and we're going to reset everything again, and we're going to let it auto force it for us. So, again, this time we're only going to run it 60 times because we've already established the baseline a couple of times. And again, we're doing that plan, the package type of 7. Now we're going to clear the procedure cache again in the database and do a package type ID of 0. So we can change the baseline again to a different plan. Then we're going to change it over to 20. And then we're going to check our recommendations. And we're going to see right here that it's already forced the plan for us. So this says the last good plan is forced, and it's in a verifying state. So that means it's went ahead, because we've got a score of 51 this time, it's went ahead and forced that plan for us. And now you're just automatically got a performance improvement on the system. So neat stuff there, especially when you consider you can do that across your whole server and get a 20% increase in performance. A couple of things outside of the SSMS. I did write a PowerShell function that you can run across all your databases and get back data for your system that'll tell you, based on your execution count, your duration, your CPU, your reads, writes, or memory, or a row count. They've added some more fields with 2017 that I haven't updated this PowerShell function with yet. And you can tell it what server to run against, get the top number of queries back, and it tells you how many hours to look back and get a minimum execution count. And I've got an example of how to run it there. And it's just running some queries in there. So these all can be edited and changed. So I'm just going to get back the top one on my system. And it pops it up in a grid for us so that we can sort it and do whatever we want with it, because we have a couple of different databases on here. We can take this information and go and troubleshoot whatever we need to troubleshoot on the system, because if we had a few different databases on there, 10 or 12, we might need to go in and try to figure out which one of these is running at our high CPU or duration. This is our CPU one, and say, oh, this one is a high CPU. That's the one we need to go and troubleshoot, rather than trying to go through 20 different databases trying to find the right one. I also wrote a widget for the new Ops Studio that's came out. Hopefully everybody's heard about this. This is the new cross-platform, going to be the cross-platform SSMS. And you can write your own widgets in here for your databases. So if you go in here and manage your databases, I wrote a widget that just shows me my weight stats for the last day, so I can see what my top weight stats are for the day. You can go in there and change it for the hour if you want to. I have a blog post that's linked in the slide deck on how to set this up, but it gives you a nice, quick, easy way to go in there and see, okay, for the last hour or day, depending on how you set it up, what your system's been waiting on in that particular database. And by using that blog post too, it might give you some ideas of some other widgets that you want to set up to see on your system. That is it for demos. I assume no questions.
So Tracy, can you hear me any better now?
Yes, I can.
Awesome. Okay. So I did have a question earlier, but you couldn't hear me now. The first one I think you probably answered, but I don't think it'll hurt for you to go back a few slides to handle it. And it's,
okay.
Can you just highlight the major differences between 2016 and 2017 versions of Query Store?
Yes, the major differences are right here where you get the auto plan correction. So it'll go in, and if you set it up to do it, it will force plans for you on your behalf, so you don't have to go in there and find the ones that have regressed in performance. It'll automatically detect that regression and force that plan into action. And it'll unforce it if it decides it's no longer the best plan. And it also tracks weight stats for you into those 23 categories I was talking about. So,
okay, thank you.
Those are the two things.
And let's see, the other question, does turning on Query Store impact the performance of the database? And as a best practice, would you recommend turning on Query Store only for a few days as needed, or leave it running all the time?
Okay. As far as impacting performance, we turned it on all like 500 systems we had at my last shop, and we did not notice a performance impact. And we have a system that has 600 databases on it tracking data. So I would say if your system is a teeny tiny system, you might notice a performance impact, but all our systems have at least 64 gigs of memory and at least 2 CPUs. So we did not notice a performance impact. 2016, they made a lot of improvements just performance-wise in general. So I think that's why we didn't notice a performance impact with Query Store.
So I think my general advice having to do with that is to treat turning Query Store on just like you would any other change and start in a lower environment. Start in staging and monitor it, see if it matters.
Yep, start and test and see what happens. Yep.
Start in QA or UAT if the system is kind of set up similarly. Maybe even turn Query Store on during a lower performance or a lower hit time on your system. Measure it there. I would never advise that you go out and turn anything on your production system without knowing what it does in your environment.
Yeah, and that's how we started. We started in development first, and we did not notice any impact there, and then we moved to QA, then we moved to staging, and then we turned it on a few things in production, and then a few more things in production, and so forth. But we were able to eventually turn it on everything in production without any issues.
Right. I just find that a lot of places their dev setup isn't remotely like what
production. Yes. Yes. Ours wasn't either.
So
even our staging wasn't like production, and we were still able to do it.
Work on my box, right?
Yeah.
Okay.
Yeah, I agree there. Start in the lower environments and move up from there. So I would recommend if you're going to use it, just once you turn it on and you verify that it's working, to leave it on, because you don't know when you're going to need it to want to turn it on and off for the second question.
Right.
So especially if you're going to be using it for auto plan correction, because once it's off, it can't do it. It can't track your weight stats. It's not, it's not available to you for what you need it for if it's off. So you don't have that black box to go back to find out what's running if you're turning it on and off. So, if you've got it tested out and you've got it running, you might as well just leave it on. So.
Okay, so I just took presenter back from you.
Okay.
Just to go back. So let me do this so that you can, you'll be able to find this recording up. Hopefully later today, I'll get this put up. I will tweet it, tweet the link to it so that you don't have it. And so that if there's any piece you think you missed and you want to go back to, that'll be easy for you to do. So again, Tracy, thank you so much for doing this for us today. We really appreciate it. And good luck in your presentation this evening in Virginia Beach. I know that the Hampton Roads SQL Server User Group is very happy to have you, and I'm sure it's going to be a great recording. So thank you all very much, and hopefully we will see you back next month.